everyone. Hope you're enjoying these video lessons. Today we're going to look at a continuation of chapter 6.2, multiplying and dividing rational expressions. And let's get right into an example. Okay, so here we have a rational expression. And what we have is that these two rationals here, you see this larger rational and this kind of smaller looking one, they're multiplying together. And whenever you're multiplying things in fractions, you always multiply the top with the top and the bottom with the bottom. More technically, the numerators together and then the denominators together. Okay, but this, can you imagine, multiplying this here with this whole expression here? It just might get a little complicated. So let's show you a trick where it makes it a lot simpler. Okay, so the first thing that you want to do is you want to see if you can factor the numerator and the denominator out of each of the pieces here. We're going to look at them as individual pieces first of all. So let's first get in and factor that 2x cubed plus 10x squared plus 12x. And the first thing that you should notice is that you can factor out an x and a 2. So let's factor out a 2x first. So factor out a 2x and we end up with x squared plus 5 plus, 5x plus 6. Okay, and then notice in the denominator of that first rational, we can also factor out a 2x. And then we're left with an x plus 7. Okay, so you're going to notice right away, oh, isn't that interesting? I've got a 2x in the numerator and I've got a 2x in the denominator. Something just might happen with those two. Let's continue and see what goes on. So what can I actually factor out of this second portion right here? So let's split this up. This can't be factored any further. So this is a difference of squares. Notice you've got an x squared and you've got a 9. They can both be square rooted. So let's deal with that. Right, so x plus 7, that can't be factored out any further. And we've got our x squared minus 9, which is x minus 3, x plus 3. Okay, wonderful. Let's continue to factor this out because it can still be factored. Let's do that in our next step here. 2x, and then we've got x plus 2, x plus 3. Divide that all by 2x and x plus 7, and then just rewrite the next rational here. So we've got x plus 7 and x minus 3, x plus 3. So if you notice here, we've got this first rational, okay, and this second rational here. And the terms in there are being multiplied with each other. But if you notice, we've got an x plus 7 right here in the numerator, and that's dividing out an x plus 7 in this denominator here. And that divides out, and you end up with a 1 and a 1 there. Okay. Notice if we have any other common terms like that. We noticed earlier that we have a 2 in the numerator here and a 2 in the numerator there, so those divide out. And then we've also got an x here and an x here. Okay. And then we've also got an x plus 3 and an x plus 3. So if you have the same thing on the top and on the bottom, then you can divide them out. They equal 1, and then you end up with a much simplified version of the rational expression as we did above. One thing we didn't do here, we didn't state these restrictions. So why don't you guys hit pause, and what I want you to do is I want you to state the restrictions from this stage right here. Okay? So hit pause and see if you can guess what the restrictions are. Okay, so now you're back, and remember when we stated restrictions that we said that we didn't want anything to make the denominator 0. So what's going to make the denominator 0? Well, for one, x can never equal 0 because of this guy right here. For this one, we've got x cannot equal -7. And then for this guy and this factor, we've got plus 3 and -3. So we'll just write plus -3 just like that. Okay, so our final step, we're going to rewrite our simplified rational expression here. So the only thing I have left is an x plus 2 in the numerator, and in the denominator I've got x minus 3. So there's your answer. Okay, so you're going to have to make sure that you're a little more focused for this one, because you just might fall off of your chair if you don't remember one crucial step. This here, we're dividing rational expressions. So if you notice, we've got this divide right here. And remember when we were younger and we had to divide fractions, what would we do? So if you had, let me just kind of run you a quick little example here. If we had something like 1/2 divided by 2/3, what did you actually do? Do you remember that? We went 1/2, and then we multiplied, and then we flipped that second fraction. So then we actually had 3/2, and then that equaled, we multiplied across, and we ended up with 3/4. Okay, so just remember that, and let's go to it, similar to what we did in the first example. So we want to factor the expressions in the numerator and the denominator. So let's get started with that. Factor the expressions here. So we've got x plus 7. X plus 7, can't really do anything with that. Factor x squared minus 9. That's x plus 3, x minus 3. And we've got, let's just rewrite exactly what we have. Divided by, and then factor x squared plus 9x plus 14, and we get x plus 7, x plus 2, factor the denominator there, we get, you can take out a 3x first, and then you end up with an x minus 3. Okay, so this is where we're going to do our flip. Okay, we're going to multiply by the reciprocal. So we've got x plus 7, x plus 3, x minus 3. Okay, and then this is where the magic happens here, people, right here. So that divide sign changes into a multiply, and then we flip this fraction here. So we've got a 3x, x minus 3 in the numerator, x plus 7, x plus 2 end up in the denominator. Okay, now we need to state any restrictions on the variable at this point. Okay, so we're actually going to do it in order this time. So what are my restrictions? Well, if you notice here, in the original question, we've got x is in the denominator, so x can never be equal to 0. Then we've also got this here, x minus 3 business. So that means that x can never equal positive 3. Okay, now one thing we need to notice is after we've done our flip in this stage, we also need to state the restrictions, because this factor and this factor end up being in the denominator at some point. So we can't actually ever have those guys being 0, or else, you know, the world blows up when the denominator is equal to 0. So x can never be equal to -7 and -2. Okay, so those are all our restrictions right here. And now we can go on and we can reduce the terms of our rational expression and end up with our answer. Let's write it in, let's see how this light pink shows up. Okay. So we've got a factor of x plus 7 here. Okay. And we've got a factor of x plus 7 in the denominator. We've got a x minus 3 up here and x minus 3 down there. That becomes obsolete. That divides out to 1. And is that it? Yeah. Okay. Sometimes if you're not keeping track of it too nicely, it can get a little messy. So we've got now 3x in the numerator. That's the only thing left in our numerator. And x plus 3 and x plus 2 in our denominator. And also, remember, our restrictions are right there. Okay, let's have a look at some more examples where we mix them all up together so you can figure it out. All right, so here's 4 questions for you to try now, and I want you to remember to look at the denominator, see what's going to create a 0. So right here we've got your x, y, a, and b. So what number is going to make anything become 0 there? Here, let's see. Well, you know what? I'm going to give you guys a chance to do this. Press pause and then give it a try, see how it goes, and I'll show you the solutions in a minute, okay? All right, so hopefully you actually pressed pause and you worked out the solutions. I hope you were successful, that you remembered to factor things out and state your restrictions, and then reduce. All right, have fun with the assignment.